Okay, so for tonight, I've actually planned to say a few words about how I imagine this meetup to work or happen in the future. I will give a very small or high-level overview over xlwings, really what it can do, but I would not like to go too much into details, just because I would like to keep it relatively short tonight. Because we have also kind of a second talk. So that's why I would like to stay high level, just to not drag it on for like too long. And then my main talk actually will be about automated testing. So it's like one topic I just picked out of the many things that you can do with xlwings, something that has proven to be kind of very valuable to a couple of users that I know. And then I will hand it over to Daniel, who is a senior lecturer at the Columbia Business School and actually uses xlwings in real life to teach hundreds of students machine learning. And so I'm very curious to learn about that process and what learning process he went through by using that combination. So before I get started, though, I wanted to mention just a few words about myself and what we do. And as I said, I'm Felix. I'm the main author of xlwings. It's about 5 years old now. And this kind of started off what now became a little company. So we're really just 3 people. And our goal really is to provide innovation for Microsoft Excel. So there's a lot going on, most recently from Microsoft itself, but then other things are a bit older, like the VBA editor, let's say. So we try to make things a little bit more modern and kind of bring a developer's workflow to Excel. And so what I mean by that is a couple of things that kind of fit into that process. So I'm just running through the different solutions that we kind of offer. So the first one, I don't have to say too much about it right now because we're going to talk about it during the rest of the talk. So this is xlwings. It can do a lot of stuff. We will get back to that. Maybe just the last point worth noting is we're going to add basically professional support plans. So we've had customers who actually kind of actively asked for professional support plans there. Then the other product that we manage is called xltrail. And xltrail is really, think of it as GitHub for Excel. So it's version control for Excel. And it actually is able to connect with your Git repository. So if you push your workbooks into Git, then you can connect xltrail with your GitHub or wherever that is. And xltrail will actually show you the content and also the diffs of the spreadsheet and also the VBA code if you use that. Then we do have another open source tool, which is called GitXL. So if you do use Git, then if you do use Git and if you do use VBA, then it is worth checking out. As I said, it's free. It allows you 2 very cool things. One is the git diff command. So you can actually do a git diff either in the command prompt, or if you use source tree, which happens to be a popular kind of GUI solution for Git, then from Atlassian, the guys behind Bitbucket, so then it actually also works within there. And the best thing is you only need to install GitXL and it just works out of the box. And the other thing is you can actually do a proper merge with Git and VBA. So if you really do work, let's say, on a VBA add-in that has a lot of VBA code, then you can really truly work on the same file with 2-3 people and then really do the merges. And if there is a merge conflict, then it will show it to you directly in the VBA editor, which is kind of nice. So that's like the screenshot at the bottom right. Then xlwings continuous integration is more of a consulting solution. I will jump over that because I'm going to look at it during basically during the main talk. And then finally, we have this thing called xlwings reports, which is not quite out yet and which may be part of maybe at some point a bit of a bigger pro package. And so the deal here is that we found out that a lot of people are actually using xlwings for reporting. So that means they just automate the data acquisition from different APIs, from SQL databases, from other spreadsheets. They consolidate it, they number crunch it, and then they just spit it out into the different cells. And we thought there's probably like a better way to do that. So instead of just assigning, let's say, a pandas data frame to a specific cell, you actually create a template in Excel, and you just put in your variable names into double curly braces, and then if you call the create report function, it'll automatically put those variables into the right place. And that has the advantage to like the classic, cell A1 value equals my data frame. It has the advantage that kind of the report builder or the business user can actually independently of the Python programmer can change the templates. So when the user, the business user actually, let's say, moves down one table a few rows, then there is no code change needed, which is actually quite nice. And that's about it. So that brings me to the first point, to the Meetup organization. First and foremost, I would like it to be a community event. So I'm very happy to create more of these, and I'm very happy to do more talks. But I am also very happy to have other people talk about what they do with Excel. And that doesn't need to be necessarily only with xlwings. So Daniel is like really nice that he already jumps in the first meetup and does such a talk, such a community talk. It's much better than what we see in London. I've already had 2 talks and nobody else was talking so far. So already much better in New York in the first one. Exactly. And so, yeah, as I said, I mean, it can be about xlwings, like Daniel will talk about how he uses xlwings, but it can also be about anything else that is, innovative. It can be about Power BI, it can be about how you use Excel and the new dynamic formulas, the new dynamic arrays, anything that you do with Excel that you might think that other people are interested in. Yeah, and so just shoot me a message, and it can be anything between 5 minutes and 50 minutes. And so at this point, I would like to give you a little overview over xlwings as such, because there's a couple of different functionalities that we have, and I believe there is quite a few people here who may have heard about xlwings, but may not have really used it. So I think it's kind of worth to just show the different capabilities. If you have a lot of questions, then maybe we kind of take them maybe for later, like for when we kind of socialize, because otherwise we may get bogged down here. So yeah, 4 different functionalities: automation, kind of controlling Excel from Python, then classic macros, clicking a button and the Python magic happens in the background. Then user-defined functions, you write proper user-defined functions but in Python instead of Excel. And that, by the way, is the only function that is only available on Windows. All the other things are cross-platform. That is Windows and Mac. And then finally, we have most recently added the REST API. So I'm going to show you in a second how that works. So let's see how this all happens. So let's get back to the first point, automation. So automation, what I mean by that is you just fire up, for example, a Python interpreter. You say import xlwings as xw, and then you just say, for example, workbook equals book, and then this will open a workbook in the background. And now it's just very easy. You can very intuitively, it kind of follows the API from VBA, but in a Pythonic style. So you can just write here. You can actually use this notation here too, and just write something, and then you can read it back into into Python again. So this is really just for interaction, and that's kind of the most basic way of using xlwings. And it's also the way how you can use it for building scripts. Doing this automation thing, you can use it to interact with Jupyter notebooks. You can do about anything really that you want to do. And it's especially nice because you can use data frames and NumPy arrays, and it just accepts it and passes it back and forth. But let's move on to the macros. So let's see, hang on, let's quit actually here. And so, for example, as a macro sample, I could show you. So this is a classic Monte Carlo simulation, and the classic example, like where sometimes people, they really misuse Excel, so they try to create loads of pseudo-random numbers and just paste them into Excel, and the Excel becomes like 50 megabyte big, and it doesn't really work as well anymore. So with xlwings and Python, you can just really write it in NumPy, and you can actually, you know, create 10,000 and 100,000s of random numbers. And the only thing really that resides in Excel is this part here, where you have the inputs, and then that part here where you have the outputs. So it's just, you know, it's final numbers, and the workbook is like really, really small, and the whole business logic. So I mean, this is really a kind of an example where you use Excel as a user interface, as a pure user interface, and I believe Daniel is probably kind of using it in that way, so we might hear more about that. And so in the background, you would just have this Python code where you have a section that just reads in the values here, then does the actual business logic down here, like the simulation, and then in the end spits it out again to Excel. So there's that. So you can make tools. That's the macro part. And then you can do UDFs. And for UDFs, I have this example here. So one of the annoying things that I always found in Excel is that you don't have like a correlation function that accepts more than like 2 data sets. And so that is something that xlwings allows you to very, very easily solve. So let me just jump to the end here. So you have this, all this return data from stocks, and then you would like to have a correlation. So somebody sends you this Excel file, and you just would like to have some correlation matrix. And so xlwings in that sense makes it very easy, because, let me make that a bit bigger, because you can really just make a new correlation function. And the beauty about that is you can really leverage the tools you have in Python. So you can really just say that whatever you pass into that function is supposed to be a data frame. And so basically all you need to do is, you know, do dataframe.core, and that just lets pandas do all the work for you. So you don't have any of the hard work to re-implement some correlation function. So it's really just making whatever pandas offers you, making that available from Excel. And so ignore the lower part for now. So that you know, brings us back to here. You would go into your xlwings add-in and import that function. And once that's imported, then you can actually just use it like any other function. That is, if my mouse reacts. So we're gonna go to my Coral function and give it some input. Hang on. I'm getting there. All right. And then you're gonna give it this as an input, and then you can see that we have instantly the nice correlation matrix on the right-hand side. And if you're wondering what this is, like the little frame around it, so that's indeed the new dynamic arrays I mentioned before. One of the most awesome features that Excel introduced just recently. You may not have that yet in your corporate environment, but we actually have a little hack on xlwings, so you can always kind of mimic that by using a specific decorator, so you can mimic these dynamic arrays. And then you can actually go further and say, Excel is also very bad at doing correlation plots. So you can, for example, that matplotlib is easy to use for correlation plots. So you can go further and say, that you would just like to build a correlation plot with that, and then paste in that little heat map into Excel. And the nice part about it is that it's really interactive. So for example, if I go over here and then have this return changed into a constant return, then you can see that the picture did update itself. So that's really an easy way to leverage the infrastructure that Python offers you. And here's the code. It really uses Seaborn, which is kind of a wrapper on top of matplotlib. So these things are really easy to do with xlwings. And don't worry about the code samples. We'll put them all up on GitHub. And so that was the quick example about user-defined functions. And so to conclude that first part about this very high-level overview of xlwings, I would like to show you the most recent addition to xlwings, which is a REST API. So a REST API is kind of a nice way to expose a spreadsheet well over kind of web technology. And all you have to do for this to work is you have to type xlwings REST API run, and it will give you access to, for now, the read API of Excel. So this means you can use it from, let's say, a web tool that you're building, and you would just like to access data from Excel. So that's kind of a classic use case if you try to move away from Excel, you try to migrate into a professional web-based tool. But very often what happens is that you can't possibly replace the whole Excel workbook in one go with a new web app. So what we, for example, did in one of the consulting projects we did is you start on one end on the web app, and then some functionality you leave in the Excel app and just make it available through the API. So as you can see here, this is just an Insomnia REST API client. I can use this to query my book, my specific book, and the sheets and the range. And so when I send that, I will get all the data that I have in my sheet as a JSON object here. And the different things, so like really the formulas, the values, and so on and so forth. The other way you can use it is actually if you have, like, let's hypothetically assume if you're in finance and you use a Bloomberg terminal and you have this spreadsheet that does all the heavy lifting, but depends on the Bloomberg terminal, then you could use this to actually broadcast your data. Obviously only derivative data that is covered by the license, but that's another kind of use case you could use it for. Let me see if there was another use case for that. Yeah, there's another use case. So I know from a German bank, they are using it to monitor legacy workbooks. So like if you have Excel workbooks running on a Windows server, then they just use this API to kind of periodically ping ping it, have in a monitoring dashboard, show the status, and maybe trigger a macro here and there. So that's kind of also a good way to really deal with legacy data or legacy workbooks. And this was basically the basic introduction. And so I would like to, as I said, I would like to not spend too much time on the second part, so that Daniel has enough time to show us his magic, what he did with xlwings. But as I said, I picked a topic of automated testing, kind of unit testing with Excel and xlwings, because it's a very nice use case of Python and xlwings, and I have seen quite a few companies actually doing it. And it's one of these pillars in modern software development that are just kind of really the cornerstone of solid software development. So I don't know like how big the knowledge is of people here about unit testing, but it's really not a difficult concept. So it's all about you have a function and you want to automatically test that this function is really doing what it's supposed to be doing. And so I have this very easy mySum here that just sums two values together, and I want to test it down here. So Python comes with a integrated infrastructure, and you have basically that the test is basically just that. So I would like to test two inputs, 1 and 2, and just make sure that the sum is going to be 3. And I use the assert equal and then call my function with the inputs and just really compare it to the expected value. And if it's correct, I get an OK. If it's not correct, then I don't get an OK. And so real quick, I could show you this over here. Let's close that. So this is gonna be here, and let me just open that file. Test sample. So you see, it's the same code. So I would just really I could call it, and it runs and it's okay. And then if, for example, somebody goes there and for some reason changes it, and I do rerun the code again, then it will fail, and I know that I have broken something. So it's very important, like if you go in and refactor big parts of Excel or of your code, then it's very important or very good to have test coverage, because that will prevent you from making errors that otherwise would go unnoticed. And so that's really the basic principle of unit testing. And so how can we use that to test our Excel workbook? And there is a very nice functionality in xlwings which allows you to actually call VBA code from Python. So, I mean, eventually we are going to test the cell logic, formulas, and VBA code, but I'm going to start by showing you how you can test VBA code. So like, there's still many people who does still write VBA code. A few, right? Yeah, some are guilty. So it's a very easy way to actually automate that testing, and you don't need to do anything funky. You can really just rely on Python's infrastructure. So the nice thing about xlwings is you can really very easily map a VBA function into a Python function. At least it looks like that. So we have then in the end here we have mySum, and I use like the underscore to basically say that this is the Python part. So when you call mySum, it will in reality call this Excel VBA function, which is defined here. And so this is really all you need to do. You need to say macro, reference the function name in VBA, and that allows you to really just trigger a VBA function from Python. So that's really, it's basically one line. and you have all you need to execute a VBA function in Python. And so to have a VBA unit test framework in Python, there's a bit of boilerplate you need to do, but you can almost ignore that. So what I'm doing here at the top is here is really just like a setup class which runs at the beginning of this class. It really just creates a new instance of Excel. It opens the book that wants to be tested. Then it does, map all these VBA functions that you want to use. That has the advantage that, you can have 50 tests below, and they all refer to the same VBA function. So you really just need to do the mapping a single time. And at the end of the class, you just tear down everything. So you save the workbook so it doesn't complain about changes, and you quit the application. But then, as before, the actual test is really just like one line. For example, here, let me see, I think I have that bigger here. Yeah, so this is really all there is to a test. So you can use assert almost equal just to get around like floating point issues. And then you can just compare the expected result, 3, with whatever you get back from executing the actual VBA function. And that's about it. So that's all you need to do to run a VBA unit test. And yeah, let me just real quick show you how this looks. So I've got my workbook here, and I've got my code here, my test code. So let's say we're really just looking at this guy here at one of the tests, really just a VBA unit test. So I run this. Let's just, for simplicity reason, let's just run all of them. What's it called? Test. Yeah, and I think it expects it to be closed, so let me just repeat that again. So I just ran all the tests. You see, I will get to the other tests in just a minute, but it ran the 6 tests and all passed. And let's just really focus on this single VBA unit test, the one that we've been looking at here. So I can go into my book now. I can change that VBA code, which is here. So same game again. So somebody makes a stupid mistake and replaces the plus with a multiplication. And then so when we rerun the unit tests, then the test should fail. The one that does the VBA unit test, as you see here. There's another test failing, and we'll just get to that in a minute. So it complains about that whatever it expects, 1 and 2 is equal to 3, doesn't equal to whatever it gets back. So you know that there is an error in your VBA code, and you can go in and fix it. And so that's how easy it is to really do these unit tests. I was jumping over that slide here. So there's actually different kind of tests that you can do. So what I just showed you is like the classic unit test. It really just tests one single VBA function, or you could use it to test a single cell formula. Then there is integration tests where you actually, let's say you run a full macro. It calls a couple of different user-defined functions, or a couple of different functions in VBA all together. So you kind of test it as a whole. Or you can imagine like you change a single input in an Excel spreadsheet, and then you go like to the 20th sheet and test that the output that kind of propagates through all the sheets is what it's supposed to be, what it's supposed to be. And then like the number 3, what I call the cell logic test, we can see in a minute what that is. And the fourth one is actually what I've also heard that people have to do, is kind of an alternative implementation test. So when I was back in working at the bank, then people would just, for example, use a cubic spline interpolation function, and people would go, you know, search that cubic spline VBA. You get like this page of VBA code, you copy paste it into Excel, and that's about it. And so SciPy, for example, has a built-in cubic spline function, and unlike the one you've just downloaded from the VBA forum, the one in SciPy is unit tested and peer-reviewed and has been used by probably thousands of users. So, if you had to choose, I would prefer to use the one from SciPy. So what you can do is now really, you can say, okay, I want to stick to the VBA implementation, but at least I want to compare it to a proper kind of reference implementation. And so that's also very easy to do. You just take the output from that VBA function, from that page-long VBA function, and you compare different inputs and see if the output matches the one that SciPy cubic spline gives you back. So these are kind of different style of tests that you can all do. And so this here is really just a sample how you can unit test a formula. So you can see down here, I'm actually using a couple of like edge cases. I'm using a negative input, a 0 input, and a positive input. And I'm really just setting the value of here, which is basically my input cell. I'm setting that value, and then I am going to grasp the result from B1 here, and then I'm really comparing if the result is what the function actually is supposed to be. So that's kind of an example of how you could run a unit test. Then this here is like, okay, you have an export to PDF function. Let's say this is an integration test for VBA. It generates a PDF, and Python makes it really easy to check, is that PDF file really there? Like simple things that are so hard to do sometimes in VBA. And then finally, that's the cell logic test. So yeah, let me just show you what I mean by that. So you can have, for example, this financial planning kind of sheets where you just add on a regular basis, you add a new data column to the right. So you would do like this, like maybe for May, right? And at some point, somebody comes here and say, okay, what happens if we do 60 here and it's Friday evening and they don't go home, and then everybody forgets about it. And so if you do have like a dynamic kind of cell logic test, which is this one here, then you can actually really go through that dynamic range and check for whatever, like a sum in that row. And so when you run that test, and let me just fix that that VBA part from before, so we just get one failing test. Okay, so let's do that. Let's close it, and let's run the test suite again. Then you will see, or we would expect that dynamic test to fail, because it actually does test if we have if the sum is really, from the above two rows. And I mean, you can do whatever is important on a certain sheet. You can go crazy and really test the things that matter to you. And so that's really how these unit tests work. I've mentioned that before, the alternative implementation test. So in that case, really just for the record, it's like, comparing my sum here with the built-in sum, but the example I gave you before about the cubic spline probably makes a little bit more sense in the real world. Just to mention that, I've shown you how to use the unit test module, which is built in, so it's very nice. So you basically don't need anything else than just Python and xlwings. But then there is a large community, I believe, who use PyTest, which does, it's a third-party module and makes a lot of things a lot easier. You have to write less boilerplate code, for example. So definitely worth checking out. And then also Nose or Nose2 is kind of an alternative runner to run all those tests. So something you may be worth looking into. And then finally, I mentioned that at the beginning, that continuous integration is basically running the tests automatically whenever you track your workbooks with Git. So that's kind of this holistic thinking about how to treat Excel workbooks like just standard code objects and really treat them like developers do treat their code. And so I would like to show you this real quick. You can actually trigger that. You can actually trigger these unit tests by checking that workbook into Git. So I have done that. So I can actually do this git commit, and then I can do whatever my message is, like some changes. And yeah, and then I can push that, and I should have, hang on, and I should have the error still in there. And so what I'm doing currently is I'm pushing this into my GitLab repository, which kicks off a pipeline. And that pipeline really runs these unit tests here on the server. And you can see it's just currently running. And it does run the tests, and now it should fail. And so if you now go to repository, I mean, you can have your CI/CD pipelines send you a message when something fails. So somebody checks in a new version of Excel and it fails, and then you can instantly see that by the red button here, and you can go into the pipeline, see which test failed. So it's a very nice way to automate things, to make people not forget about running their unit tests, and to kind of get visibility. Like if you're a manager and you want to make sure that your team sticks to the rules and passes the test, and that's an easy way for people to actually look at what's happening inside. And I believe that's pretty much it, what I wanted to show you about automated testing. So I think it's a very powerful tool. Where do I have the slides? Here. And yeah, with that, I would like to thank you for your attention, and feel free to connect on LinkedIn. Always happy to have a chat.